Greeting to respective lecturer of Integrated Design Project 1, Semester 2, Session 2021-2022. My name is Tan Yao. I am from Group 5 and today I am going to present on minor department. Here are my teammates for minor department. Next, I will present the topic of water reticulation. First and foremost, we have to look into the project design criteria. Then, we proceed to the design of water reticulation system and finally the pipe layout. A water supply system must have these parts such as the source of supply, the treatment of water, and the distribution of water to consumers. Here are the guidelines for design distributed system based on Suruhanjaya Perkhidmatan Air Negara (SPAN). Here are the components for water reticulation system. Next, we proceed to average water demand. This value shows the average daily water demand for different types of buildings in the development plan. Next, we proceed to design of water reticulation system. First, we compute the value of top water level, bottom water level, and half of total water level. The proposed level of tank is designed at 70 meter and the tank height is 5 meter. Based on the calculation, we obtain that the BWL is 70 meter, TWL is 75 meter, and half of TWL is 72.5 meter. This table shows the daily total water demand at each nodes that can be used in the E-Panet to calculate the residual pressure, velocity, and head loss. The total demand is 913,281.60 liter per day. Next, we determine the type and diameter of pipe and the flow velocity. We choose HDPE for pipe type and the diameter is 100 mm at first. The length of each pipe is calculated by using E-Panet. The velocity must more than 0.3 meter per second. From E-Panet system software, we obtain the information for each pipe such as the value of length, diameter, roughness, friction factor, unit head loss, and velocity. The elevation of nodes was determined based on the proposed level of the ground design by the earthwork department. The nodes and pipes were buried about 1.2 meter to 3 meter below the ground surface as stated in SPAN requirement. The base demand calculated from table 4.1 was inserted as an input in the E-Panet software. The head and the residual pressure then automatically calculated by the software based on Hazen-Williams equation. From the E-Panet software, there are 44 junctions, 0 reservoirs, 1 tanks, 58 pipes, 0 pumps, 1 valves, flow units is CMD, and head loss formula is Hazen-Williams. Next is the skeletonization of water reticulation system. We use ring system as water can be delivered in 2 directions to any spot. Next, we determine the location of fire hydrant. The fire hydrant was determined by placing a fire hydrant for a radius of 180 meters. Next, we determine the water demand. The value of water demand is determined by the type of the buildings in the development area. The areas that are covered by each node are obtained by using the AutoCAD drawing. Then, the daily water demand of each node is obtained by multiplying the area with the water demand specification to obtain average flow and peak flow rate. The total demand is obtained from table 4.1. The peak flow is calculated by multiplying the average flow with 2.5 for urban area. Next, we design the tank dimension. Since we use circular tank, with the diameter of tank is 35 meter, the height of water tank is 1 meter and the capacity of design water tank is 962.11 meter cube. Next, we proceed to calculate TWL, BWL, and pressure head at first node. Here shows the Bernoulli equation. Since pressure head and velocity head are located at the water surface, their value becomes 0. The value of head loss can be calculated by using the Hazen-Williams friction loss equation. Since we use HDPE pipe and the coefficient roughness is 120, from table 4.2, the length from first node to second node is 38.70 meter and the diameter of pipe is 250 millimeter. From here, we calculate velocity of water flowing out of tank and head loss. Then we obtain the pressure head at first node, which is 7.99 meter greater than 7.5 meter. This is the pipe layout for each pipe and node. Next, I will present the topic of erosion and sediment control plan. Here are a few principles of erosion and sedimentation control plan. The project site is located in Ulu Tiram, Johor. The total area of the project site is 44.39 hectares. Hence, we decide to divide the area into 3 zones, which each zone will be divided again into 4 sub-areas. The planned site layout and the area are as below. For erosion control, ground covers can provide long-term stabilization of soil. Here are the planning considerations for seeding and planting. Here are the design criteria for seeding and planting. The maintenance requirements for seeding and planting are shown here. This slide shows the limitation in seeding and planting. Next, we proceed to estimate the rainfall by determining the average recurrence interval and time of concentration. The formula of time and concentration is the total of overland flow time and time travel in drains. Values of Horton's roughness and Manning roughness coefficient can be obtained from table 2.2 and table 2.3. Next, we determine the average rainfall intensity. Based on the station ID, we can obtain all the constants that we need from the table. Next, we determine the peak flow by using rational method. The formula is Q equals to CIA divided by 360. For Zone 1, the area is 1.65 hectare. By using this value, we proceed to calculate concentration time TC, average rainfall intensity I, and peak discharge estimation QP. The results are shown in the table below. To design temporary drainage, best hydraulic section of trapezoidal shape is used. Since the flow discharge obtained is higher than peak flow discharge, the dimension of channel is okay. The table shows the checking for inlet for all three zones. Based on the result, all the zones have higher design discharge than peak discharge. Hence, the design is okay. This is the design plan for drainage. This is a long section view of drainage. Next, we proceed to soil loss estimation. The equation is given as shown here. A is annual soil loss, R is rainfall erosivity factor, K is soil erodibility factor. LS is topographic factor, C is cover management factor, and P is support practice factor. R is assumed as 14,800. The equation of soil erodibility factor is shown here. K factor is calculated for each zone. LS factor can be determined directly from MASMA table 12.3 by interpolation. Slope length and steepness factor of each zone is obtained by directly observed from the contour map for existing, controlled, and uncontrolled. The value of C and B is obtained from the following table. This is the overall result of C and B factor for each subzone for existing, uncontrolled, and controlled. This is a sample calculation to obtain annual soil loss of Zone 1 for existing. This is a summary of soil loss estimation for Zone 1, Zone 2, and Zone 3. Next, we proceed to sediment yield estimation. We use modified universal soil loss equation as shown here. This is a sample calculation for sediment yield per storm event for uncontrolled and controlled. This is the overall result to calculate sediment yield per storm event for each zone. Next is the design of sediment basin. Wet sediment basin is chosen as the design since the proposed site has fine grains loam with a higher than 33% clay content. Table below shows the design criteria and sizing volume for sediment basin. We conclude the soil test data at site. All zones have same hydrologic soil group, which is B, wet basin type. The percentage of particle size distribution and area for each zone is recorded. Next, we determine the basin dimension, sizing of basin outlet, and trapping efficiency. This is a summary result of sediment basin for settling zone, sediment storage zone, overall basin base, and sizing of basin outlet. This is the detailed drawing for wet sediment basin. Silt fence is constructed to prevent the stockpile topsoil from dissipating into the catchment region and inhibiting sheet flow. Here are the application criteria of silt fence. Lastly, the construction of check dam is needed to prevent erosion. Here are the design criteria of check dam. Next, I will present the topic of cost and estimation. Gantt chart is done to track the duration of work done to minimize the cost. Here are the results from earthwork calculation. We obtain the total area on site, total cut volume, and total fill volume. It is used to calculate the cost estimation before and after reduction. The table shows all rate and cost for earthwork equipment. The cost is used to calculate the overall cost before and after reduction. After consider all the equipment costs, the cost for second attempt is lower than the first attempt, which is acceptable. Since the percentage difference obtained is higher than 30%, it means that the cost reduction is very effective. That's all from me. Thank you.